Okay, this is a companion video for the worksheet because many of you did not do that right. So just here we go. This is just an example problem. A 20,000 watt motor lifts a 5 kilogram object 3 meters in 2 minutes. How much power was needed to lift the object? Okay, so you've got power is 20,000 watts. We don't need that because we are not looking for the power. We're looking for the power that was needed, not the power that it had. Okay, so then we are going to have to find power. So if you'll remember, power is equal to work divided by time. But what is work equal to? Well, it could be equal to force times distance, or it could be equal to the change in energy. In this case, we can use either one. For this one, I am going to use the work is equal to the change in energy formula, but I'm going to specifically change the potential energy due to gravity. So we are lifting this object, so it's changing the potential energy due to gravity on it from, let's say, 0 potential energy initially to 5 times 10 times 3 finally. So if you do this, you would get 30 times 5 is 150 joules of energy. And now we need to find power. So power is equal to work divided by time, 150 joules, divided by 120 seconds, which is 1.25 watts. Power is equal to 1.25 watts. Now you'll notice this is not the power that it had. It had 20,000, but it is the power that it used. It only used 1.25 watts. So in other words, this was the amount that was used, and this was the amount that was provided. Okay, so there is a difference between those two. So what we did again was we needed power, so we did work divided by time. Work was equal to the change in energy. The energy that changed was the gravitational potential energy. That changed from 0 at the bottom to 150 at the top. And then we did 150 divided by 120 seconds. Again, 120 seconds because it was originally 2 minutes. All right, so that's that one. Let's take a look at another one. This is just continuing on. If it was 100% efficient, how much could it lift in that same time period, that same height? So on this one, what we're going to do is we are going to have 20,000 for the power, and we are going to use this one this time because we're going to say it's 100% efficient. So 20,000 watts equals, well, what does it equal? So it equals the work over time, but we just said that was the change in energy over time, and over there we said the gravitational potential energy final minus the gravitational potential energy initial over time. Okay, again, work equals change in energy equals final minus initial gravitational potential energy. Now the initial is just 0, and the final is mgh divided by t. So this becomes 20,000 equals, sorry, what was the mass? 5 kilograms. Forgot to write that one down. Oh, sorry, we're looking for the mass because we want to know how much it could lift. So we're looking for the mass, m times 10 times 3 over 120. Now, if this machine was 100% efficient, it would be using all of its power to lift the object. So we would have to multiply up by 120 and then divide by 30. And we would get 80,000 kilograms that it could lift. So if it was 100% efficient, it could lift 80,000 kilograms. It's not 100% efficient, so it lifts 5 kilograms. All right? And you'll find this on most machines. Most machines are nowhere near 100% efficient. You can look up the figures for different stuff, and you can tell that they're very, very inefficient. It's just how much power is being, like how much power does the motor use? Like how much power does it generate is nowhere near as much as usually used by the machine. Just to know that. All right, so how efficient is it? We take the total amount the machine used or produced, the total amount of power produced by the machine, and then we're going to take the total amount used, which we determined earlier was 1.25 watts. And to find a Efficiency rating, just in general, you take the amount of something used divided by the amount provided, and that will usually give you an efficiency rating, and then multiply it by 100. So on this case, we're going to be 1.25 divided by 20,000 times 100. 1.25 divided by 20,000 times 100, and we were 0.00625% efficient, an incredibly low rating. It's true, but it is similar to the ones that y'all should have had. So over here are some numbers that you may wish to consider to look at for your worksheet. So keep that in mind. Anyway, make sure you turn those in. We'll say by Friday.